if you want to create an end application, you need both physical trust and digital trust. Now, this physical trust was missing. What we are developing right now is a consensus layer on how do you achieve agreement or consensus on physical world attributes. What's the location of an asset? What's its connectivity? What's its resource capacity? A great application that we saw while this was being developed is DePIN, for which physical assets is core. DePINs are a way to commoditize new things. So these sort of applications require, by their very design, a trust broker. Let's say you're using Netflix. Utilizing Netflix requires somebody to store that movie, a CDN to host it close to your location, an underlying ISP to serve it to you. So that involves like 3 DePINs to provide one end service. For anybody to construct this sort of service, you need trust. And if these DePINs can trust one another through a shared trust broker, you can enable a whole new class of use cases. Trust builds coordination. Coordination leads to economics.
Welcome to We Are DePIN, a podcast focused on the world of DePIN projects. Each episode, we invite projects to discuss how they are revolutionizing the world of DePIN and Web3. Our goal is to keep you informed about everything happening in the DePIN space through insightful discussions. This podcast is brought to you by Minima, the embedded blockchain. Minima is a fully decentralized layer 1 blockchain that can embed and run a full node on edge devices. Minima is not just another blockchain. It's a fundamental shift in how decentralized networks can operate. Its lightweight architecture allows it to run a full node on chip on any mobile or IoT device, making it exceptionally adaptable to scaling any decentralized physical infrastructure networks. Minima's technology is now being supported by an expansive and engaged community of over 50,000 node operators. So join us for this next insightful discussion and enjoy the episode. Hey Ranvir, how are you?
Hey Sina, I'm good. Pleasure to be here.
Yeah, pleasure to have you as well. It's great to finally have you on the podcast. And it'd be great to jump in straight away because there's just so much that you guys have done. And I don't know how we can fit it all into 30 minutes. So I want to basically get straight into it. Witness chain. What was the sort of birth of that? What was the sort of like process of ideation?
Sure. So like witness chain started 3 years ago, right? And our core concept was that blockchains are very powerful. Like they have solved the problem of composability and development of permissionless apps across a variety of different use cases with completely new business structures, right? But blockchains were very constrained in the sense that they're very endogenous. So a blockchain can only read state within itself. It's not connected to the physical world. So the most powerful component of blockchains was trust, right? But blockchain's trust was digital trust. And if you want to create an end application, right, you need both physical trust and digital trust. Now, this physical trust was missing, right? So what we started with developing and what we are developing right now is a consensus layer on how do you achieve agreement or consensus on physical world attributes. Like, what's the location of an asset? What's its connectivity? What's its resource capacity? And so on. And with this, we envision that there's a huge class of applications that this would open up. And blockchains would move beyond tokens and DeFi. Right? A great application that we saw while this was being developed is DePIN, which is for which physical assets is core. So yeah, I think that's how we started 3 years ago. We were initially like focusing on one sector of DePIN, and what we realized is whatever we have developed is something that can be used for almost all verticals in DePIN space.
Wow. Okay. Very interesting. So just to clarify, it's bringing real world attributes onto the blockchain. Yeah.
In a completely verifiable Byzantine fault token.
It sounds very impressive and it sounds very cool. But my question is, I guess, like, why should it matter? Like, why? What is the problem it's solving? And I guess, like, why should people care?
Sure. So, like, whenever you're using, let's say, a service, like let's say you have a phone plan with your carrier, right? You have an agreement with that carrier that, okay, I will get 5 GB of data and I will pay you $20 for it or something like that. Now that agreement is something that can be legally enforced. So there are legal rails behind it, and then there are There are reputation rails that the big company has that are behind it. Now, if demand side of a DPIN, of a certain telecommunication DPIN, wants to use this service, how can they be rest assured that they are using a stranger's base station to communicate with you? How do you enforce these sort of contracts? Now, you can't just use blockchains to do it, because blockchain has no idea whether that data was served, whether that bandwidth was available at that location, right? But utilizing a service like ours, a platform like ours, you would be able to know that, yeah, there was resource capacity available at that place, then you're able to solve it, right? So this is a class of application which is very DePIN specific, where you would be able to know it. Now expanded to multiple DePINs, right? So let me take an analog of DeFi. Like just having Uniswap would be useless if you don't have like other ERC20 tokens, stable coins, borrow lending protocols out there, right? So the value in all of these ecosystems, in some sense, economics itself is coordination. And if you want to enable coordination, how can these smart contracts talk to one another? That's because they have this underlying trust layer of Ethereum or Solana, whatever, that makes sure that like every contract behaves honestly. If multiple DePINs have to talk to one another, why would that be the case, right? Think of a supply chain by supply chain, I don't mean a traditional supply chain. Let's say you're using Netflix, right? Utilizing Netflix requires somebody to store that movie, a CDN to host it close to your location, an underlying ISP to serve it to you, right? So that involves like 3 DePINs to provide one end service. Now, for anybody to construct this sort of service, you need trust within. Now, Web 2 does it by like legal agreements across multiple companies, but Web 3 is a better way to do it, which is just use contracts. And if these DePINs can trust one another through a shared trust broker, you can enable a whole new class of use cases for this infrastructure. There are a lot more exciting use cases that I want to talk about, maybe later. But this was the trust builds coordination. Coordination leads to economics. That's our principle.
But it sounds like a colossal task in order to be able to do that, right? Like bring physical assets, basically the attributes of those physical assets on chain.
It was very heavy research. So we have been working hard in the past 3 years, and we have essentially solved the problem. Now, the great thing about physical world is there are multiple dimensions of physical attributes, right? So there is location, which is the core, right? You are a DePIN, you have to be decentralized to ensure your coverage, right? Your utility. But there are a few more, like, okay, what's your resource capacity? That varies across DePINs. So we have built out we have solved for the core physical attributes. Those are location, connectivity, compute. But there are like very DePIN specific physical attributes that needs to be developed. And we have launched a platform that enables like people to develop that and deploy it on our Watchtower network. So I would like to say it's multidimensional. We have solved the core components of that dimension. And then we have created a platform where it's easy to deploy this thing for other dimensions of physical assets.
I see. What's the value for the DePIN provider? Is it like they get more like data? What does it translate into? What's the core value for the DePIN provider?
You mean DePINs? So there are a whole suite of utility. First is you make sure. So if you're a DePIN, to set up your supply side to begin with, you are rewarding agents for providing capacity and service. Now, if you don't have a way to like verifiably determine if a capacity was provided or a service was provided, then you're giving away your incentives to farmers, essentially. And we have seen this happen across multiple DePINs where like people would just claim to have certain capacity to get rewards and then not provide any supply to be there. So it solves this core bootstrapping problem for DePINs on the supply side. On the demand side, it makes it easy for consumers to like trust you. So like, what did AWS solve? The core thing that AWS solved is like if I order an EC2 compute, I will get that. It's commoditized, and there is a trust broker, which is Amazon, which makes sure that you'll get it. Right? For that level of confidence to be built up for consumers, you need some sort of trust guarantees on the performance of that DePIN. And like if you have a platform like ours, this provides trust guarantees, and that would increase consumer confidence. That would increase consumer demand. There's other aspects on the consumer side as well. So the Netflix application example that I mentioned, right? It involves like a use case which cannot be solved by a single DePIN. So if a single DePIN tries to develop that use case, it can't do it. So a third-party developer has to do it, and it has to coordinate across multiple such infrastructure providers. And through our platform, they can do that. Right? But what this leads to on a DePIN side is now you have demand in use cases where we previously were not able to get that demand. So right now, the DePIN's way of gathering consumers is like, okay, directly approach consumers. But what's even better, like let other parties find consumers for you. And this sort of approach, where you have somebody else develop a chain of for a use case, leads to that sort of organic demand, which is, I would say, much needed in the DePIN space.
How's this sort of, on a practical basis, how do these DePINs interact with your platform? Like, how do they? I understand the value, but then on a practical basis, how does it work?
Sure. So I think let me explain the architecture briefly. So we have what is called a DePIN coordination layer. This coordination layer is a place where DePINs can register their physical assets. So let's say you're a compute DePIN, register your compute servers. If you are a communications DePIN, you register your radio assets, and so on. Now, a watchtower network, which is a decentralized network of, you can think of watchtowers as validators in a very trivial sense. They run these consensus protocols for proof of location and proof of bandwidth that would prove those attributes for that assets. Now, for those assets, for those physical assets, to be able to prove it, they download a very lightweight container called a prover that will help them participate in those challenges that watchtowers initiate, and that proves their location. So on the DePIN side, the lift is pretty minimal, which is they have to install the sidecar of watchtower on their assets, and then they can just through smart contract integration, they can just get they can just know if those assets have validated their attributes.
And what's been the uptake, I guess, on the DePIN side so far? Like, what's been the reception?
I think it's been fantastic. We have more than 30 partners, and even outside of DePINs, we have use cases where this is something which is required for if you look at DeFi. If you want MEV, like, you need location, right? How does TradFi solve MEV? By location and making sure latencies are correct. So that's an application we have found. Then there are compliance applications that require, okay, your users need to be in this continent or on this country. That's where location is needed. So there are classes of almost all verticals of DePINs are covered within this, and also outside of DePINs, this is something which is required for a lot of other blockchain projects.
Thing with physical assets, though, is that they can, depending on what they are, but they can move, they can change. Their attributes also change. How do you guys sort of account for that stuff?
So this is a pretty so each whenever you run, for example, a proof of location challenge, we call it, it determines the location at that point. So if you are anticipating, so let's say you are a DePIN which is just doing compute and server level compute, right? Most of your supply is coming from server farms. Then you need to perform these tests maybe once every month, right? If you are a DePIN who is also doing compute, but your supply is through an app or a mobile phone, they're moving rapidly every day. Then you can perform that test on demand, or you can schedule it to happen every hour. So it's a programmable system. your DePINs or the application developers which are utilizing this can like program it to be triggered either at regular intervals that can be as frequent as possible, or on demand, like whenever they need that proof.
Mm. But the owner, because if you go down the supply, so you have the DePIN providers, but then you have, I guess, like the physical asset owners or the ones below. So the supply side, would they have to input any sort of data anywhere? Is there a paper trail that would go onto the blockchain, or like how would they input any changes to the physical attributes?
It's a similar system as like whatever the deep like whatever the DePIN has, right? So an asset provider has to like, so let's say they, based on their DePIN use case, they would participate in proof of bandwidth, which computes your speed. So they have to like tell that, okay, this is the amount of bandwidth capacity that I have on the system. But the thing is, in most of the DePINs that need this kind of proof already have some sort of an estimate, or the user, the supply side will already input it. Okay, I can serve this amount of bandwidth for my VPN use case or for my ISP use case. Similarly for location, if the DePIN doesn't have that, then we ask the supply side, like whoever is installing the sidecar, to include that additional information. Be proven that can be proven later. In most cases, we make it integrated within a DePIN's flow itself. So, for example, we have like what we do with a lot of these DePINs is their assets are not just running provers; they're also running challenges together. So they are a watchtower themselves. Right? If they're watchtowers themselves, like they need to like provide this information, but they do it through the DePIN itself.
You mentioned the word watchtower quite a lot. I know that's part of your product. So what is a watchtower? What does that actually mean?
Okay, so think of it this way: in blockchains, you have validators that validate your digital state. Watchtowers are equivalent of that. They watch for these physical attributes. So it's a general umbrella. It's any server which has either compute or sensors, right? So let me give you an example. In proof of location, a watchtower is a node that runs the challenger. So the way proof of location works is at a very high level. It's a form of triangulation, but the triangulation happens over the internet. So you have this watchtowers distributed throughout the globe. They're connected to the internet. They don't have special hardware. They're just compute servers on the internet. They run ping over the internet to the DePIN asset that needs to prove its location, right? And then we map this cryptographic ping delay to actual distances through an internet delay manifold that we've developed. We do some Byzantine fault tolerant triangulation, but through all of these process, we determine the location of the block. So in this process, you can think of these watchtowers as just servers with some compute that witnessed the distance of that physical asset from their location. So as a witness, that's a watchtower saying, hey, this node was 100 kilometers away. And then other watchtowers give other witnesses, right? And then all of those are combined together to prove location. So the short answer is a watchtower is a validator, but for physical attributes.
I understand. That makes sense. What specific areas of DePIN do you see this as being the most successful or having the most sort of strong use case match?
If you look at location, right? If you are a DePIN, it's in your name. You're a decentralized physical infrastructure network, and decentralization is a core utility. If you don't have location decentralization, if you're doing telecom and all of your operators are in one city, then it's not a DePIN, right? So this location is core to almost all DePIN's utility. Right? They're useful only if they have coverage. So location is something I see useful in all class of DePINs. It's not just for coverage. If you're a compute DePIN, like co-location is very important to you. If you're some DePIN which is in some regulated space, compliance is very important to you. So that's where I think we have seen proof of location to be used in almost all DePINs. Proof of bandwidth is something which is important, or like bandwidth is connectivity. It's important for very important for DePINs that are tied with connectivity. So think of your telecoms, ISPs, think of VPNs, CDNs, those kind of attributes. And then proof of diligence, which tries to compute, is important for compute-based DePINs. But I would say everything falls, like proof of location is something that every DePIN needs.
That's really, really interesting. And where do you see witness chain going forwards into the future in terms of either use cases or product iterations, like community building? Like where do you see the future of it going?
Yeah, so I think we have been on. So let me update you on the current status. We have been on mainnet since April. We are leading AVS on EigenLayer. We are launch partners. So we currently have like more than $8 billion in crypto economic security through restaked ETH. So we are pretty much covered on the supply side as far as the crypto economic security angle is concerned. What we are building is a broader watchtower network where you have more devices. Right? We're covered on the economic side. We need more devices out there. So we're partnering with DePINs to have watchtowers deployed throughout the globe in large quantities. So I think, and we will also be releasing an app that it can help anybody run a watchtower on their mobile phone. So right now we are in a watchtower expansion phase. If anybody is watching, we have our client ready so that you can run proof of location watchtower on your laptop right now. You can download it separately. You can download it through a DePIN partner, whatever way you want. Once this is set up, we're already integrating with our DePIN partners. We anticipate to see the effects of these integrations pretty soon.
That's very, very cool. What about like outside of DePIN? So where do you see that going as well? I know we spoke a lot on DePIN, but of course it's a DePIN podcast. But I'm also curious on other areas.
So think of broadly in this way, right? Like I see blockchain's evolution in phases. So your first phase was a blockchain by itself, your Bitcoin, your Ethereum. You can only do token transactions with that. Right? Then blockchains became connected to the internet. And now they can start competing with Web 2. Right? This happened through Oracle's Chainlink. Now we are connecting. This is the next phase of blockchains, where a blockchain is now real world aware. So think of like location aware dApps. You have dApps which is aware of like real world events which are not even on the internet. Right? We know internet has not been great at like conveying real world information. There's a lot of noise out there. But like through this layer, like blockchains can have capacities which is beyond what like Web 2 can provide right now. So we'll not just be competing on the decentralization philosophy. There'll be an additional utility that this brings. So that I can think of a few class of apps here. Like one very simple app would be, hey, you can have okay. Since I just mentioned this, you can have an MEV resistant DeFi protocol. If you can know where a transaction originated and where it was processed, you can counter any latency advantages that you can have through co-location, right? Co-location and through like other MEV principles. You can have apps where you're not only you can build media. Okay, so this is a very wild idea. You can have. So right now, media is consumed. Like media is essentially different verticals of media agencies who are seeing an event and then transferring it to their end consumers, right? And there's no shared security across these media agencies. If you have a verifiable observation layer, people can just know whether this event happened or did not happen at that particular location. And the list goes on, but like I think I see a lot of, this is on top of what we discussed earlier, which is compliance. You can use it for compliance. You can use it for several blockchain protocols need decentralization for their security. Apart from blockchains like Ethereum, if you're developing something like an MPC secret sharing protocol, you need to make sure that all of your parties are unique and geographically distributed. So proof of location serves as a proxy for that decentralization. Okay, I think I've said a lot of use cases. We can like yeah.
No, I mean, off the back of those answers, one of the last questions I want to ask you is, going forward, I guess, like, where do you see different like digital proofs and DePINs evolving? Like, where do you see that going? Because I know you guys are a layer, but then as a whole, like, where do you see it going?
See, I anticipate a lot of there are a lot of projects coming up which are kind of building commoditization markets for all of these DePINs. So I think of you're aware the commodities markets in terms of volume are bigger than like stock markets, and blockchains are stock markets. DePINs are a way to commoditize new things. You can commoditize compute now. You can commoditize weather data or whatever. So these sort of applications require, by that very design, a trust broker. Right? And what we see evolving, at least on our platform, is these markets being set up. Initially, they'll be set up for attributes that you can prove on our platform. But then, let's say a new market came up. Let's say there's a new energy market, energy commodities market. We don't have proof of energy on top of us. Then we will see like proof of energy capacity being deployed on our platform that can prove this. And there's something which is already happening right now. So we see organic evolution of these sort of proofs, where you would have these market opportunities that these DePINs don't want to miss, and them contributing this proof to this layer with very high shared security, and getting access to the market.
Very interesting. Okay, last question from me, Ranvir, before we wrap up the podcast. It's been an absolute pleasure having you on. Is what is your favorite use case of DePIN outside of what you guys are immediately doing? I know you guys aren't a core DePIN company yourselves, but you're providing infrastructure to the space. So I guess it would be a good answer to hear what you have to say. But yeah, what is your favorite use case for DePIN?
I have a lot of favorite use cases, but I'm a fan of use cases where you actually there's a lot of AI wave going on right now, right? And if you're building decentralized AI, you need its foundational layer, the compute layer itself, to be decentralized, right? So I think projects that like enable decentralized compute for AI projects at scale is something I'm very looking forward to. A lot of our partners are working into that. But I'm also like excited about DePIN projects that are. We started in the communications, telecommunications area when we started Witness Chain. So I'm very bullish on like DePINs that are building. Decentralized. And the reason I was bullish on that is because for things like communication, you need your assets to be close to you, right? Like if you look at small cell like 5G, millimeter wave 5G deployments, those are very expensive to deploy because you need to deploy it at every block, right? And that's where DePINs really shine. So any like communication-based use case is something I'm excited about. One of our close partners just launched Dawn, and we're working closely with them too. I'm also excited about projects that are, there are Web 2. There are Web 2 companies who are moving into, like with established infrastructure, who are moving into Web 3. Because what we see is like establishing DePIN that is working is a very hard endeavor, right? And companies have already solved the technical problem of like making a network run and then utilizing the decentralized economics, I think would have a easier path to like getting demand, and I think those are my 2 cents.
Amazing. Ranvir, thank you so much for joining me on the We Are DePIN podcast brought to you by Minima. Thank you so much. It's been an absolute pleasure. We're going to wrap up the podcast there. How can people stay in touch with you and Witness Chain going forward?
You can reach out to, so we are pretty active on Twitter. You can reach out to me at 0x Ranvir or Witness Chain at @Witness Chain. You can also check out our website, witnesschain.com. You can find, if you are interested in running Watchtower, you can find instructions to deploy our proof of location client on our documentation.
All right, fantastic. Thank you so much again. And I'm sure we'll chat very soon. Thank you.
Anyways, thank you.
Thank you for listening to today's discussion, brought to you by the embedded blockchain Minima, the only layer 1 blockchain lean and compact enough to run a full node on chip or on any mobile IoT device. If you're new to DePIN, subscribe to our YouTube channel and follow us on Twitter to stay up to date. Thank you so much for watching again, and we'll catch you in the next episode.